Alright, so this is a question, specific question from your textbook that a student wanted me to go through. Page 506, number 21 out of the actual text. Page 500, number 27 if you're looking at the PDF file. I'm going to present to you two ways how to do this problem. Alright, the first way is elimination. And the second way will be substitution, right? So over here on elimination, let's start there. So if we want to eliminate this thing, I'm looking at options here. I've got 3, 1, and 2. I've got negative 2, 1, and negative 3, 4, negative 2, 6. Alright, none of them are super easy right now, so I have to do some work. So what I'm going to do is maybe start by eliminating the x's in the top two equations. Alright, so I'm going to rewrite the top one. And I'm going to multiply the middle one by a number that's going to create an opposite coefficient in front. And that number is negative 3. So right now I'm multiplying the whole entire middle equation by a negative 3. And then add them together. So we have a nice cancellation here. Negative 5y, positive 10z. Alright, great. Next up, since we started with that elimination of the x's, we're going to want to do that again. So let's work with the bottom two now. So I'm going to multiply the the middle one by negative 2 this time. Alright, so here we go. Negative 2 times x minus 2y plus 4z equals negative 6. Alright, that was the product of the middle equation by negative 2. I'm going to rewrite the bottom equation. Add them. We get a nice cancellation here. Negative 5y plus 10z equals 2. Alright, so if we're kind of keeping track of what we've got these two equations, and we want to kind of add them together. And remember, for elimination, I mean, it's often called the addition method, but you can also subtract if you want to. So when we set these things up, you'll notice that they both have exactly the same coefficients for y and z. So I'm actually just going to subtract them. When I subtract, I need to put this whole thing in parentheses. Alright, it's the same as multiplying it by negative 1, by the way. So when we do that, minus, they of course turn into a plus. This turns into a negative as well by distributive property, and this is negative 2. Alright, so if you look, we've got cancellation, cancellation, and negative 10. So 0 equals negative 10. That is obviously not true. 0 cannot equal negative 10. That's called a contradiction, which means there are no solutions. Sometimes you'll see, especially in the back of your textbook here, I just noticed that the word that you'll see is called inconsistent, which means this system doesn't have any solutions to it. Nothing can fit in there that'll make all three true at the same time. So sometimes it'll be called inconsistent. Alright, but we've reached a contradiction right here, and we write no solutions. Now when I worked this out before, I think I ended up with a ton of fractions and other craziness because I decided, I think, to eliminate the y variables. Alright, I'm not going to show you that, but just keep in mind that there is a potential to get a ton of fractions and or decimals when you're doing these problems, and there's nothing wrong with that. It just it's going to take a little bit more skill. All right, so that was the elimination method. Now let's go through this, see if we like this any better. We can use substitution when we're talking about three equations when we kind of notice that our coefficients are kind of nice and neat. All right, so these coefficients in this equation are nice and neat. There's a positive one here and a positive one here. So what you can do if you want is solve the middle one. Let me rewrite it first. Solve the middle one for x, let's say. So we bring everything over. So x is equal to negative y plus 2z plus 3. All right, and then substitute that whole thing. That whole thing can be substituted in equation number 1 and in equation number 3. What that'll give you is two rather lengthy equations with only x's, with only y's and z's. So I'll show you the first one. Here we go. 3 times x. X, of course, we're going to replace with the red thing. Now we're back to this equation, minus 2y plus 4z equals 1. Let's simplify that. Again, this right here was our red substitution. So let's simplify that a little bit here. Just doing some arithmetic here, some combining like terms, moving some stuff around, and we're done. Alright, so that was the result of substituting our red little box back into this equation right here. Alright, let's do the same thing for this equation, the third equation. So we're going to rewrite this whole equation, and instead of using the letter x, we're going to replace it with that box. So here we go. 2 times negative y plus 2z plus 3. We're back to the original equation, minus 3y plus 6z equals 8. Simplify. Negative 2y plus 4z plus 6 minus 3y plus 6z equals 8. Combine like terms, negative 5y plus 10z plus 6 equals 8, and get that number over there. We get negative 5y plus 10z equals 2. Alright, so a lot of stuff going on here. We have this equation and we have this equation ready to go. Alright, those are two equations with just y's and z's. So what I'm going to try to do here is bring them together and just kind of move them so they're vertically aligned. And we are ready to go. We've got two equations with the same two letters right here, just with y's and z's. Again, what I'll do is maybe multiply the top one by negative 1. That'll leave me with positive 5y minus 10z equals negative 2. And I'll just rewrite the bottom equation. Add them together. We get cancellations right here and here. And our final is 0 is equal to negative 10. And that's exactly what we got up here as well. That's not true. That is a contradiction. So we say no solutions. Alright, so from here, if that kind of made sense to you, you can pick either category, either method. You can see that they're both just about the same amount of work. what I'm going to do now is go into what would happen if you wanted to actually take this whole system and solve for y first. So if you don't want to continue, just press stop now, but what I'm going to do for you is take it one step further and show you what would happen if you were to solve this system by elimination and using the y coefficients to solve first. It kind of gets a little crazy. Alright, so caution. Oops, sorry. Caution, there's some craziness ahead, okay? So here we go. And this is real life. If you like I said, when I first did this problem, I decided to get rid of the y's just because, you know. So I kept the top one the way it was. I multiplied the whole middle equation by a number that will get the y's to cancel, which of course is positive 2. So I got 2x plus 2y minus 4z equals 6. Nice cancellations right here and here. Whenever two things cancel, that's usually a good sign. 3x plus 2x is 5x equals 7. Alright, and here we go with some fractions. So there's the x value. Okay, great. If we take that and we plug it back in to, you know, one or all of these equations, right, we can get down to the point where we're just left with two equations with y's and z's. Alright, so my next task is going to be to take this value and plug it back into, let's plug it back in to these bottom two equations. So here we go. 7/5, which is x, plus y minus 2z equals 3. 2 times x, well, before I do that, let's simplify this. This is the middle equation. 7/5 I'm going to bring over to the other side, so it's 3 minus 7/5. Well, that's 1.4, so that's 1.6, which is just, I guess, 8/5. Alright, if you want to use decimals, you certainly can, but I'll keep it like that for a second. So that's the middle equation ready to go. Bottom equation, 2 times x minus 3y plus 6z equals 8. This is 14 over 5. You just take that 2 multiplied by 7. So we want to move the 14/5 over to the other side. To do that, we simply subtract it. So 8 minus 14 over 5. Well, I can do that over here. 8 minus 14 over 5. 14 over 5 is 2.8. So the difference there would be 5.2. Alright, if we're sticking with our fractions, first of all, decimals are fine, but if you're sticking with your fractions, 5.2 changes to, let's see, and we're looking for a denominator of 5, it'd be 27 over 5. Nope, 26 over 5. Sorry. Okay, so I'm going to erase this just to keep our fractions. You don't have to do this. You can, if you're a decimal person, you can use that as well. But that is the equivalent of 5.2. Alright, so now we want to kind of bring this equation over. And we want to bring this equation over and line those up this way. Okay. And solve them. Okay, well, let's see, we've got fractions. That's kind of crazy. So one thing that you can do, one trick that you can utilize here is whenever you have fractions in your equations, what you can do is clear them out. All right, if you don't want fractions there, clear the denominators out. Alright, nothing wrong with that. You can get rid of those denominators by multiplying by the denominator. So clear them both out of there. And rewrite 5y minus 10z equals just 8. 8/5 times 5. Now we're going to do some what do you call that? Distributive property. Same thing here. Negative 15y plus 30z equals 26. Okay. Alright, so this is kind of crazy, right? We've got, well, it looks a little nicer now, actually, but you know, there's a lot of stuff going on. But what I'm going to do now is simply solve them. Right? So again, I need to eliminate. So I'm going to take this, I'm going to multiply it by something that's going to make these coefficients opposite. That would be a 3. Alright, so I have, let's see, 3, I'll go a little bit above here. I've got 3 times 5y minus 30z equals 24. I'm going to rewrite the bottom one. And I'm going to add them together. These cancel, these also cancel, leaving us with 0 equals 50. That's not true. That's a contradiction. So since it's a contradiction, write this little symbol there. That's not really a good symbol. You write this little symbol right there. That means that when the two arrows point to each other, that's a contradiction, and this is an inconsistent system. No solutions. Okay, so we've got, you know, I just gave you 3 different methods. There's a lot of stuff to do there. You can pick your favorite way. I would probably say that the substitution is a little bit easier than either elimination method, but I gave you some options, so hopefully that helped.